Right, let's proceed. Okay, Solomzi, sit down. Right, so here, as I was saying, therefore it is helpful to have a convenient reference. Is everyone back here? Okay. Now you don't switch it on here. Okay, just okay, just a second. We're putting on the TV here. I don't have to write this. We've written it already. Just explanation. We're just talking about the volume being affected by temperature and pressure. Right? Then we start. All right, okay, let's continue. Right, hello? Can you stop there, please? Can you stop there? Right, so as I was saying, therefore it is helpful to have a convenient reference point at which to compare gases. For this purpose, standard temperature and pressure are defined as your temperature must be standard for all of them, 0 degrees or 273. Pressure, it's 1 atmosphere. 1 atmosphere is the same as 760 torrs or 76 millimeter mercury, or you can have 101.3 kilopascals or 101,300 pascals. This point is often called STP. You must just know your pascals and your kelvins. That's all. You can ignore these other equivalent units. Right. This applies to any gas that is at standard temperature and pressure. Right. At standard temperature and pressure. Right. I have a problem here. My battery is about to die. I need to remove your chargers, guys. I need to remove your chargers again. Right, okay. All right. Wait. Can I just finish up here? For example, 2 moles of hydrogen gas will occupy a volume of 44.8 cubic decimeter at a standard temperature. Basically, what are we saying here? We are saying all these substances here, all right? At STP, they will occupy the same volume. We've got hydrogen, it will have the same volume. Oxygen, same volume. Nitrogen, same volume, because the conditions are the same. And what else? They all have the same number of Avogadro's particles. Are we together? But if I've got 2 moles, what am I going to do? I have to double my volume. So there's another formula that you need to write. The formula, please, can you write this? The formula says number of moles is equal to volume over VM. Right? That's another formula for number of moles when you speak it when you dealing with molar volume. Number of moles is equal to V over Vm, where N is number of moles. N is number of moles. V, it's your volume. V is your volume. V is your volume. And Vm is your molar volume. Vm is molar volume. Molar volume. And molar volume at STP. At STP, your volume is going to be, at STP, your Vm is going to be equal to 22.4. At STP, 22.4 cubic decimeters. If your volume is not STP, If your volume is not, if your conditions is not STP, you cannot use 22,4. If your conditions are not STP, you cannot use, so you must look for the word STP, standard temperature and pressure. They'll give you the volume if they want you to use that VM. They'll tell you maybe it's 25, because the higher the temperature, then the higher the volume. So it will depend. For example, if they say to a room temperature, then your volume changes maybe to 27, 28, depending. All right. So for you to use 22,4, it must be written standard temperature and pressure. If the question is silent about that, you don't know whether it's a STP or not, so you cannot use this. Right. So now we have learned how many formulas for calculating number of moles. Now there are 4. Number 1, mass over molar mass. Number 2, number of particles over Avogadro's number. Number 3, number of moles is equal to concentration times volume. Number 4 is this one that we have here. Number of moles is equal to volume over molar volume. Clear? Right. That brings us to the end of this. Maybe just to elucidate here, especially this point here where you have 2 moles occupy 44,8. How do we come up with 44,8? We are using this formula here. Where there's number of moles, I'm going to substitute with the 2. I'm going to substitute number of moles because I'm given 2 moles. So I'm going to have 2 is equal to, all right, I'm looking for the new volume. So the volume is going to be V over, at STP, my molar volume becomes 22,4. Then I cross multiply. This is over 1. Then I cross multiply. I'm going to have 2 times 22,4. 2 times 22,4. My answer becomes 44,8. My answer becomes 44,8 cubic decimeters. That's why here you've got 44,8. It's because we doubled because the moles were 2 moles. So the answer becomes 44,8. For 3 moles also, you're going to do the same. It's going to be 22,4 multiplied by 3. It will give you 67,2 cubic decimeters. Right, that's all for today's lesson. I'm going to post this explanation here, molar volume, together with the homework. Right, your homework is this one here. I don't know if you can see this. Okay, let me share this. Your molar volume, the homework is this one here. All right, I'll just have to edit. It's exercise 33. Right, like the first question says, what is the volume occupied by 3,5 moles of nitrogen gas at STP? So you're going to use that equation, then you cross multiply and get that. What mass of nitrogen occupies that? Please check here. Liters is the same as a cubic decimeter, so no conversion needed. 1 liter is still the same as a cubic decimeter, so you don't have to change. Are we together? All right, so you're given the volume, and what are we looking for? We're looking for the mass. Here you might have to use 2 equations here. You might have to find the moles. After finding the moles, then you calculate the mass. So you might use number of moles is equal to mass over molar mass. You might have to use more than 1 equation. Is that clear? Yeah. Right, then the last one here, it says what volume would the following amounts occupy? So for each one of them, you're going to have to calculate the volume for each one. Where you're given grams, first find the number of moles, then you go and put them on the number of moles is equal to volume over molar volume. Is that clear? Right. Okay. So I'm going to have to stop this. Then we continue tomorrow.
So,
Google Classroom. Yes.
So we use that equation N equals V over Vm to find volume.
Use mass over molar mass to get the number of moles, then you use V over Vm.
So, and you said we can only use 22.4 decimeters cube if it's at, I think you said it's at standard temperature.
Yes, standard temperature and pressure, yes.
So that's 0, so that's 0 degrees Celsius.
Yes, that's 0 degrees Celsius, yes.
Okay. And if it's not at 0 degrees Celsius, then which do you use?
They'll give you. You'll be given that
Oh,
one. They'll give you that can you hear me?
I can hear you now, sir.
Yeah?
Okay.
You answered, Zinedine?
Yes, I'm answered. Thanks, sir.
Okay, all right. Yes, Pell, you had a question? Which M? Yeah. Which M? Molar, that's small M. VM. No, that was just a subscript. It's just the way we write it. Just like on avocado, we normally say NA. That small a that we have just to say avocado. It's just a way of representing it. No? Just a way of representing it. Okay. Any other question from people online? Any other question? Let me see here. Question. Any other question here? Boykancho, Jolisha, Joshua Ndivuo, Ntokozo, Owen, Zianda, Shamase. Any questions?
No, sir. No, sir.
Right.
No,
If
sir.
there are no questions, then we're going to have to stop this lesson. Then I'm going to post this one just now on
Sir.
Google. Yes.
I'm not doing any examples today.
You wanted an example?
Yes, sir. This is so confusing, sir.
It's confusing.
Yes, sir.
Okay. All right. Let's see. Maybe I'll do. Let me do the. Okay. Let me do D. The last one. This one here. Let me do this one. If you want an example.
Yes, sir.
Okay. Right. So it says, what volume would the following amount of gas occupy? So well, I'm looking for volume, but what am I given here? I'm given mass. So what am I going to say? First, I'm looking for volume. So the formulas that I know so far, these are the formulas that I know for calculating number of moles. Number one, number of moles is equal to mass over molar mass. Right, that's number one. Number two, I know number of moles is equal to Avogadro. I know it's Avogadro's. Sorry, number of particles over Avogadro's number. All right. Then number three, I know number of moles is equal to concentration times volume. Number four is the one that we learned now, which is number of moles is equal to volume over molar volume. Right. So for this question here, we need the volume. So for me to get the volume, I'm gonna need to use the last one, which is number of moles is equal to volume over molar volume. Over molar volume. All right. So this question, we're gonna assume it's at STP. We're gonna assume this is at STP. I'll add that clause there. Right. So it's at STP. So what am I gonna say? I've got a number of moles I do not have. I'm looking for volume. So V, I don't know what is V. Molar volume at STP, I know it's 22,4. So I've got two unknowns here. So I need to first get the number of moles. So now for me to get number of moles, I'm given mass. So what am I going to say? I'm going to say in the first, number of moles is equal to mass over molar mass. All right, the mass is given there is 2,4 over ozone. The molar mass of ozone. What is the formula for ozone?
O2.
O3.
O3, yes, O3. It's O3. Oxygen is O2 and ozone is O3, right? So I'm going to get the molar mass for ozone, which is going to be 16 times 3, right? Which gives me, what's the answer there? Yeah, 2,4 divided by 48. What's the answer?
0.05.
0,05. So I'm going to get 0,05. Right, these are moles. Now I've got the moles. Now I'm going to take these moles and substitute them into this equation. So I'm going to have number of moles is equal to V over Vm. Shelton, remove your who's this one? Remove your earphones then. Huh? Okay. Number of moles, we're going to have 0,05. Right, is equal to V. I'm looking for V. And my molar volume is going to be 22,4. Then I cross multiply. When I cross multiply, I'm going to get 0,05 multiplied by 22,4. Then I get my answer. What's the answer? Huh? Okay. 1,12. Right, so that becomes your cubic decimeters. That becomes the answer there. 1,12 cubic decimeters. Yes, Pearl? Yeah, it's gonna. I'm gonna add that clause for all of them. You apply that at STP. Okay. Yes. Charlotte. Never mind. Okay. All right. Anyone? Right. Ziand, are you happy now?
Yes, sir. Yes, sir. I'm happy. I'm happy. I'm happy, sir.
Okay. All right. Fine. Okay. So now I think I can finish up this. I'm gonna cut this lesson, then I post it on Google Classroom. Then you guys will get busy. Right. See you.
Hey, when am I to made?
Huh? Come again?
Hi, nothing, sir.
Or you? All right. Okay. Right. Okay, guys. Let's meet tomorrow. Please do this homework. Then we're gonna mark it tomorrow. Can I? Okay. All right. See you tomorrow, guys.
Sure, sir.